I'm going to introduce you to two important libraries in Python, which are matplotlib and cbond. And these are very important libraries for data visualization, right? So let's say if you're doing some analysis and if you want to show to someone what are your important results or what are the main conclusions or any insight as such. So that's where data visualization comes in really handy. And if you're able to think that, yeah, I should project my results or whatever my understanding in this particular form, in this visual form. So that would help whoever is looking at your analysis or results. They will get a really good sense of what you have done, right? So in fact, if you talk about plots or charts or any such graph, right, so they are really important in terms of communicating real aspects and key aspects of your analysis. And as we say, right, a picture is worth 1,000 words, and that's what we mean by data visualization here as well, right? So in data visualization, we try to come up with very interesting plots and charts which would convey a lot of meaning and give you very good insights, right? So we'll deal with two important libraries for data visualization in Python, which are matplotlib and cbond, and they work really well with your pandas data frames, right? So they have been built. In fact, the cbond library, so it provides a lot of useful one-liner statements which can help you generate very good plots and charts, right? So that's why these two libraries are important. Of course, nobody is going to ask you about these libraries in, let's say, your interviews, but when you're doing a project or when you're doing your real job work, right? So these things will become really important aspects of your analysis and how you come up with results, right? So let's say even if you come up with some model predictions using machine learning, then you'd want to do some further analysis on top of on those predictions. And if you're able to make sense of what's coming out of your analysis using these charts or interesting plots, so it will consolidate and augment your own understanding, right? So it also develops a lot of critical thinking as well, as in you have to think that, yeah, let's say I'm given two columns in a pandas data frame and I want to show some interesting relationship between these two columns. So what should be my way to present this data in form of a chart or a graph, right? So I guess you might have worked on Excel, right? So you might have developed some line charts or something like that, but of course there are a lot of functionalities even in Excel, but in Python we can do a lot more, right? And we can do them really quickly, right? So we don't have to do a lot of things manually. So once you have, let's say, written a general template, and you can feed in the data and provide the variables which you want to plot, and you'll get very interesting charts, right? So today we'll be discussing about different type of charts that we can develop using matplotlib and cbond. And today we'll work with two data sets. First, where we'll discuss how we can use the functionalities available in matplotlib, and then once we cover that, we'll jump onto cbond, and we'll pick another data set, and we'll see how we can use the cbond functionalities on that data set to come up with interesting charts. Okay, so first things first. So in matplotlib, so this is the library, and in matplotlib you have this pyplot, which is a very important class in matplotlib. So whenever we want to do any such of any such plotting or any such thing, we'll always use matplotlib.pyplot rather than matplotlib, right? So because matplotlib.pyplot, that is considered to be matplotlib's scripting layer, or in fact, yeah, just pyplot, right? So essentially, matplotlib has been inspired from whatever the functionalities which were available in MATLAB, right? So I guess MATLAB was quite popular, let's say if you talk about 7-8 years ago, but now we have a lot of useful functionalities that we can do those particular tasks in Python, especially if we are concerned about graph objects. So those we can do with matplotlib, right? So each pyplot function makes some change to a figure, right? So there are a lot of different functions or methods available in your PyPlot class, and with the help of them, you can create a figure, you can create a plotting area in a figure, and then you can add some lines in your plotting area, right? And you can, of course, uh, decorate your plot with different labels and chart title, etc. You can add a lot of legends, etc. So there are a lot of functionalities available with us, and we'll see how we can uh, work with these methods available in matplotlib.pyplot, and those will be enough for our requirements. And again, needless to say, nobody actually nobody remembers each and every syntax, right? So let's say if you want to plot a line chart, so you can simply Google plot a line chart in matplotlib, right? So it's not even required to remember these things, but you should get a hang of it, as in you should understand that, yeah, this is the way we can project some data. The most important aspect, again, I've emphasized this earlier, but I'll reiterate, as in you need to understand what things you need to show, right? So that is upon your discretion. There you'll bring in your own logical thinking, your own critical thinking, and see that you have a data set and what information that you can project in terms of interesting graphs and charts, and which one would be relevant and which one would convey a lot of information in just one go, right? So if I just look at a plot, can I get a lot of important and useful information from that? So that is, of course, you have to develop that own thinking within yourself, right? So that cannot be taught. Of course, you can be instructed and you can be directed from that front, but you'll have to use your own intuition in in terms of how to come up with these charts, right? So let's say I can make a chart to show up a trend of sales, right? Or maybe some other characteristics. So it will all depend on how smartly you're able to assess the key aspects of your analysis and how you can project them, right? So that's at your uh, you'll use your own intuition to come up with those ideas. But of course, once you have that, that is enough, right? So once you get the gotten the idea that I want to do this particular task, now you just need to figure out how to do that. And of course, you don't have to cram and memorize each of these methods. You can simply go through the official documentation, or you can simply search over Google, go through some Stack Overflow answers, and I think that would be enough, right? So in my career as a data scientist, I didn't feel the need to actually remember a lot of stuff because everything was available to me. I only had to use my brain and mind to come up with what ways in which we can project a particular information, right? So that is really important, and I think you should imbibe that intuition or that thinking in you, because you're on your way to become a data scientist, and that is one of the key aspects, right? So you always have to think in terms of business, in terms of how you can solve the problems in a much better way, right? And this is one part of it, right? So so let's jump directly onto the data which we'll be using today to use some matplotlib utilities or methods. So the data which we have for today is price paid data, so which tracks the residential property sales in England and Wales. Okay, and this data comes from the HM Land Registry, which is based out of UK. HM is short for Her Majesty's. So this is the non-ministerial organization in UK, which uh, handles the data of land ownership essentially, right? So whatever property which are being sold, so they are keeping track of all such information and will be exploring this particular data. And this data is a very reliable source of house price information, and we have around more than 1 million records. And this data only pertains to the annual year 2018. Okay, so first task is we need to mount our drive. So I'll just do that. Okay, so it's a pretty straightforward step. If you're not aware, you can just see how I'm trying to approach this particular step. So I can just copy this code, enter this here. Yeah, it takes few seconds to get the drive mounted. It's mounted, and if I just click on this, so drive will appear. Now I need to provide the path where my data is kept. So I'll just go to my drive. Okay, I'll go to AlmaBetter, right? I hope every one of you is following the same folder structure which has been recommended, right? So that you can keep track of your files. So we are in week 3, day 5, right? So this is our data folder, and because in this folder will have the 2 data sets which we'll be using in this particular lecture, and there's one more data set which you'll be using for your assignment, right? So you can fetch it from here directly. So I'll just copy the path, and okay, so just give me a second. Okay, so now I'll add a slash over here. So this is, in fact, I can provide the proper name. So this is the directory path or the folder path. Both are essentially the same term. And so one more thing here, you might be seeing a few new things here. So of course, I'll just need to replace paths with dir path. And then this is our data, which is PP, which is price paid data for 2018. And in your read CSV function, so we can in fact provide the names of our column as well, right? So that functionality is available in the read CSV function. And also there is one more interesting argument, which is parse dates. So let's say if you have a date column which might be in string format, so you can simply provide that in parse dates, and it will properly parse that string into proper date time format. So because sale date is should be a date time object, so that's why I'm passing this particular variable as a list. Of course, this list has only one element, so I'll pass that in parse date argument. Okay, so let's go ahead and run this. Okay, of course, name PD is not defined, so I think you all are aware, right? This is the most important line, right? And okay, so it's reading the data set. It's a slightly heavier data, so that's why it takes a bit of time, but not that much. Okay, so this is what our data looks like. So as you can see, so this is the TID, which is short for transaction ID. So every residential property sale has a unique transaction ID, right? So that's how they're going to identify which sale was which, right? So this is the unique identifier, and this is very important in terms of data collection and data storage, as in each observation here, right? So each row corresponds to a particular sale transaction, right? So some guy uh, purchased a particular property sale, and that was that information was registered with the HM ministry. Okay, so we'll have a lot of information for that particular transaction or sale. So of course you need to have this transaction ID, because this will be your unique identifier. And then you have the price. So what was the price or the cost of that particular property, right? So this is in pounds. Okay, so 405k pounds, so that translates to almost 3-4 crores. Okay, and then you have the sale date. So on the date so the date on which sale happened. And then you have the postcode. So this is really important, because in UK, or you can in fact identify a particular property with a postcode as well, right? In fact, so it's a very granular way of geolocating any particular property, right? And then you have the property type. So there are different values for property type. I'll go through their definitions in just a while. Then you have the new build. Okay, whether this house is newly built, etc., or not, and then you have the tenure. Okay, so I'll go through these variables in just a while. So firstly, TID is your transaction unique identifier, and this number is unique and will change each time a sale is recorded, right? So whenever a sale is happening, right, so that particular sale will get a unique transaction ID, right? And then you have your price, so which is I've already told you. Then you have the postcode, then property type. So it has around 5 values. It can take across all the observations. So D is detached, S is semi-detached, T is terraced, F is flats, and O is other. Okay, and then you have this indicator variable or binary variable, which is newly built, and it can take only two values, y, so which is yes, it's a newly built property, n is no, that is short, that means that it's an already established residential building, right? So it's not a newly constructed property. Okay, and then you have the duration related to the tenure. So F is freehold and L is leasehold. Okay, so don't worry about this. And then of course you have the street. So the street where the property belongs to, and the locality, then the town or city, and then the district, and then of course the country. Because in country, I think, let me see, what values do we have? So stop. Okay, it's county. It's not country. Sorry, it's the county, right? So there are a lot of different counties, like let's say Derbyshire, Yorkshire. There are a lot of shares in UK. Okay, and then you have the PPT category type. So indicates the type of price paid transaction. Okay, and this finally record status, in which let's say some information was added regarding that particular sale. So that denotes this particular record status. So A will denote addition, C will denote change, and D will denote delete. Okay, so these are the values which are available in record status, and this indicates essentially additions, changes, or deletions to the records, right? So let's say if you logged a particular information or a particular observation about a particular sale, right, and later on there was some, you needed to do some clarification on that for that particular observation, so you have this particular record status, right? So let's say some information was logged incorrectly, so the person or the ministry who's in which is in charge of keep or storing this data, so they might go back and fix those inconsistencies, and they will be updating the record status whether they made some addition or did some changes, or they in fact deleted that particular thing. Okay, so this is the shape of our data, right? So it's around more than 1 million records, as you can see, right? So you have digits here after one, that means it's more than 1 million, and then you have 16 columns here. And so what we will do for our exercise, especially to explore the matplotlib functionalities, so we'll filter the data to get all the transaction for a particular year and month. Okay, so let's say July 2018. Okay, so that we can do. So, and one important thing, we'll only keep transactions of type A, which are additions, right? And we'll get rid of changes and deletions, just to avoid some confusion. And also we'll be removing transactions for property type O, which is other, and only focus on the rest four, which are detached, semi-detached, flats, and terraced. Okay, so what we'll do firstly, we'll only keep those records which pertain to additions, right? So here, this is that particular line. So df is equal to df dot log, right? And here I'm providing the Boolean expression, right? So for whatever observations this value yields true, those will be sliced. Okay, those observations will be taken into account. Okay, so here what I'm mentioning, that record status should be equal to A. Okay, and then once I have done this, right, so our df is, because I'm storing this particular slice in df only, right? So our df will get updated, and the shape of our data frame will reduce, or yeah. And then we are doing another subsetting. So here we are not considering the property types which are labeled as O, as they denote the other, and we only want to focus on the remaining four categories for the property type variable. So this is the line. So as you can see, the Boolean expression is not equal to O. Okay, and of course, for our data only corresponds to year 2080, but in fact will be more precise or more careful with our approach. So here also I'm providing this condition, right? So df sale date, so this is a date time object, right? So here there is a particular method, so dt dot year, so this essentially will give you the year, and we can equate it to 2018 because we only want to consider the data for 2018. So let's go ahead and execute these codes, and as you can see, the shape of our data frame is now less than 1 million, right? So it's around 9,60,000. Okay, and of course we have 16 columns because we didn't do any subsetting on the columns, right? So uh, let's define our objective. What do we want to explore from this data set? Okay, so our first objective is we want to obtain the trend of sales volume across months, right? So there are 12 months in a year, and we want to see how the trend of sales volume looks like, right? So essentially you want to figure out which months have the highest sales or which one have the lowest or something like that, right? So let's go ahead and try to do that. So to do this particular thing, what we will do, uh, don't worry about these things. So first, of course, uh, we're importing datetime. That's fine. That's just an extra thing. This is the important line, which is new to you. So here, what we are importing. So import matplotlib.pyplot as PLT, right? So again, as similar to PD or NP, PLT is another a very commonly used alias for matplotlib.pyplot module. Okay, so this is really important, and I think you should always use this particular alias, right? So this is PLT, which is short for plot in a way. Okay, and then this is some weird looking line, which is percentage matplotlib inline. Okay, so what does this do? Okay, so inline sets the backend of matplotlib to the inline backend. What this means that the output of plotting commands is displayed in line with within front ends like the Jupyter notebook. Okay, so if I want to create a chart, so if I include this particular piece of code, which is percentage matplotlib inline, so I'll be able to get the chart in the output. Okay, so that's why this is included, and it will be part of your collab notebook, right? So let's say even if you get disconnected or you close your notebook and open it again, so that will be present there. Okay, so that's why we're using this percentage matplotlib inline. uh, there are important uh, commands in Python which are called cell magics, okay, or line magics as well, right? So they start with percentage, and some start with double percentage. Okay, so I don't want to go into the detail of magics. Maybe you can explore them on your own, or maybe we can discuss this maybe later when we are actually well versed with the basic pandas functionalities and your matplotlib and seaborn functionalities. After that, we can you can be introduced to this idea of magics. Especially, we have two type of magics. One is line, and the other is cell. And I don't want to actually discuss about this because this is not that important at this particular moment. But we might feel the need to use this later on. Okay, so I'm skipping this for now. But remember that always use these two whenever you are doing the import command, right? So always run this particular piece of code as well. Okay, so it's you don't even have to know a lot of things. Slowly, yeah, you will be able to identify different components which are available in matplotlib, and especially in Python, and you'll yeah, become acclimatized to all those things, right? So you just need a bit of time, and yeah, you should be fine. Okay, so first thing what we want to do, because we want to find the trend of sales volumes across months in the year 2018, so we need to get the month column. Okay, so here what we can do, so how do I want to represent the months? So we will represent them using this, right? So this is our sale date. So what I want to do, I want to get this particular thing, right? So 2018 one, right? Not just one, or maybe we can have Jan, Feb, etc. But for sake of simplicity, what value will be stored in months? So 2018 one, something like this, right? So what we'll do, we'll first change our datetime object to string, and then basically extract the first 7 characters. Okay, so this is what I'm doing, right? So first uh, changing the format of the datetime object to string, and then extracting the first 7 characters. Okay, so this is I'm yeah, calling the apply method on df sale date, and storing the output of this in month. Okay, and as you know, so X here will take the values taken by sale date column, right? So all the values in this particular column, and because this is a date time object, because remember, uh, in fact, I can show you that. So df dot info, right? So sale date is a date time object. Okay, so will you will earlier be using strp time, which converts your string to date time, but strf time will do the reverse in a way, as in it will convert a date time object to a string. Okay, and here you need to provide the format of your date time object, right? So format is really easy. So percentage y, and then dash, percentage m, and then dash, then percentage d. Okay, and you can specify, and so because after operation this will be a string object only, and because string objects support indexing, and we know that we want to get the first 7 characters, right? So 0, this is 0th index, 1 2 3 4 5 6, right? So that's why we are doing this particular indexing operation or slicing operation. So let's go ahead and run this. Okay, so I think, yeah, it will take a bit of time, and then of course this is not the best way to do this. We could have used the daytime functionalities only, uh, and we could have done this, but this is another way which is not that recommended, but yeah, this will work for our case. Okay, so all right, so as you can see, now we have created a column month in which we have the corresponding values, right? So now it's time to see how can we get the sales of or property sales across months, right? So of course we can use group by, but in this particular example I've used value counts and df month dot value counts. So essentially I'll be storing this in monthly sales wall. Okay, so let's go ahead and yeah, run this particular thing. Okay, and we can find the type of this. So this is a series only. Okay, this is a panda series. uh, so I've just pinged, right? Okay, all right. Okay, so let's see. So so we can do this, and let's explore this particular bit. Okay, so what does monthly sales wall look like? uh, so let's see. So this is how it looks like, right? And let's say if we were to use the group by, so how can we do that? So df then group by, and on what variable we want to group by, so that will be month. And because we have tid, which will be the unique count, so that we can do and call our aggregate, and then we can also write a reset index, right? So now, yeah, this gives us a very good looking data frame. And of course you'll need to, yeah, rename this. So maybe I can also do that here. So rename columns equal to, yeah, so tid, I want to replace tid with let's say monthly sales. Okay, that makes, right? So this is the number we are getting, right? So for every month we are getting the total number of sales, right? But okay, so this is one way, and of course value counts is the other way. So it's a pretty straightforward problem, and I'm not sure why are you guys writing mixing up group by and value counts together, right? So essentially here will what we'll be doing, because this is the unique identifier, so we can simply do count on top of it, right? So we don't value counts, we can use it, yeah, separate from the group by, right? So you don't have to get confused between group by and value counts. Try to, right? So yeah, that's fine totally, but you need to understand how you can do that, right? So this is essentially value counts, so it will count the total values present for a particular value of the group. Okay, so in this case this is month, right? So it will give you the count of all the different levels or the categories of this variable month. And we can do the same thing using the group by, right? So you learned this yesterday, and I hope, yeah, you remember this, right? So this should not be difficult to comprehend, uh, right? So we can because we want to group by on month, right? So there will be uh, a variable on which we want to group by, right? So our month is a group in a way, okay, because for a particular month you have a lot of observations, right? So in a way month is a group, right? Because a single month can be mapped to a lot of observations, so that is a group in itself. And then of course we are providing TID, which is we know that from our data we have uh, the unique identifier, which is transaction ID for each property sale, and then we can simply call the count method on top of it, okay. And we can apply reset index so that we get the data frame, and we can rename our columns on top of it, right? So as I mentioned yesterday, right, so this is a data frame only and you can rename it, okay. So let's move ahead. So let's check out this monthly sales wall which we got using the value counts method, okay. So this is what it looks like, right? And as you know, this is a series, okay. So what we can do, there's another method which is sort index. So what here the months are not sorted, okay. So what we'll do, we'll sort the months, okay. Of course months are sorted in your group by operation, but that is not the case with, let's say, value counts, right? So it would be better if we could use the group by the data frame which we're getting from group by, but let's also try to work on this, because eventually you'll be learning new things only, right? So there is another method which is sort index. So you can sort your index, and if I provide in place is equal to true, that means it will get invoked in place. So we can run this and check monthly sales wall again, right? So I'll just put this down and try to run this and see. So now as you can see, so this is essentially sorted, okay. So we have 12 months and their corresponding sales. Now we just want to create a chart of this, so it will essentially be a line chart. So let's see how we can do that. So uh, there are few methods through which you can set the uh, size of the figure objects in your Python environment, right? So remember we imported matplotlib.pyplot as PLT, right? So in PLT you have this RC params method, right? So it will take this is particular input, okay. So figure.fig size, and we can provide the figure size as a tuple. So 10 is essentially your X units and 5 is essentially your Y units, okay. So let's go ahead and run this. PLT is not defined because we didn't run this earlier. Okay, we didn't run this, no. All right, so now this should be fine, okay. So this is sort of optional, and of course you can change the figure size with your figure objects essentially when you're creating the plot object, right? So that's fine, but this is the statement which you would like to use. Let's say you want to set this in the beginning only, and whenever you're creating an object or a figure object, so that will have those consistent sizes, okay. So let's see how we can create a chart, okay. So here it's very simple, it's just a one-liner thing, right? So this is how we can create the chart, right? So you write PLT, which is what we have imported earlier. Then there is a method which is plot, right? So this is the plot method, and as you can see, plot Y versus X as lines, and here I'll just pass my series here, okay. So remember that in this particular series, so if you there is an important method associated with a series, right? Because a series will have both indices or row labels and the values, right? So you can write dot values, and as you can see, right, so these are the values in your series, which is nothing but an array, okay. And but when you mix them with the uh, when you have the corresponding row labels or the indices, right? So that is uh, uh, that is not considered the part of the series, but essentially you're concerned with these values. But when we pass this particular series in this plot object, so it will automatically understand, these are your indices and those will be present in your, let's say, X axis, and your values will be placed along Y axis, okay. So this is a simple line, okay. And So there is another method on top of it. So once we have updated our PLT object, right? So our PLT object has been updated, right? So now this contains some data, okay? And now essentially our chart has been created, okay? So maybe if I just do this, let's see, right? So we can see the plot here, okay? And you can see on the axis we have the indices from the series, okay? So if we would not have this if we're just passing this particular array, right, which is just values, okay? And there are few more things. So as you can see here, that we do not have the X label, nor the Y label, nor the chart title, right? So we can add those things. So let's go ahead and uncomment, okay? So in this PLT object, you have this method which is title, and you can provide within the parentheses the title for your chart, okay? And then you have another method, so available for this PLT object, right? So this PLT object is now let's say if you just write PLT, right? So it will show you that, yeah, this is of module matplotlib.pyplot, right? So this is this module, and so on top of it, because we have run this particular thing, right? So now it understands that, yeah, this is a particular figure object we are dealing with. So if you just write Y label, so it will add the Y label to this figure object, right? So this is, in a way, we are creating the figure object, right? So this is the line where we are creating the figure object, and these are the lines where we are decorating our figure object, right? So we're adding title, we are adding the label for the Y axis, and we are adding the label for the X axis, right? So these are the two methods for those X label and Y label. Okay, so let's go ahead and run this and see what difference it makes, right? As now you can see, on Y axis we have total number of sales, and then on X axis we have month, and then you have the monthly sales in the year 2018. Okay, so this is a very simple way. So right, essentially you just needed to write these 4 lines, and you will have a very good plot, right? So now let's inspect this particular plot, right? So as you can see here, the highest sales was recorded in the month of August in the year 2018. The lowest was in the month of in January, okay? And then the sales rose in March, but then it dipped again, okay? Then it went up till June, then it dropped a bit in July, and the highest was then again in the month of August. But then again in September, there was a sharp drop, okay? So there could be multiple reasons, and it is upon you, let's say, because you're in charge of the entire data set, and you can come up with your own reasonable explanations of why these patterns are being displayed here, or why are we observing these patterns, right? So you can ask yourself, why was the sale so why was the sale highest in the month of August, and why not any other month? Okay, so this is important. In fact, sales was also really high in the month of November. Okay, so this is how we can in fact plot a normal sales trend across all the months in the year 2018, right? So are you guys comfortable with these 4 lines and how we can create a simple line chart? Can you please confirm yes? Right, so this is pretty normal, right? So there's nothing much to there's nothing overwhelming here. So okay, that's great. So let's move ahead. So now uh, we have another objective, right? So our first objective was we wanted to get the uh, monthly sales volume for the year 2018, but we can do much more, right? So now we want to observe the daily sales volume in the month of July 2018. Okay, so this is what we want to do. So in the month of July 2018, we want to observe the daily sales volume, right? So this was the month of July, and okay, so okay, all right. So here what we'll do, we will only take those observations which correspond to the 7th month or the July month, right? So that's why I'm yeah, providing this Boolean expression within for my data frame df, and I am storing that resultant in df only, right? So now df will get smaller again. So and here we can in fact print df dot shape, so that you can see what's happening to our data frame, right? So data frame objects are mutable, right? So you can definitely agree with this particular point. And here daily sales volume, so again I'm writing value counts for sale date, right? So because uh, okay, so sale date has a proper date format, right? So something like 2018-0101, right? That corresponds to a single date. Okay, so we can provide the value counts because our data frame now only has observations for the month of July 2018. Okay, so let's go ahead and run this. Okay, and as you can see, we only have 83,000 observations in our data frame df. Okay, so remember, when we're considering all the months, so we had around more than 9, so we had around 9,60,000 observations, right? So now let's inspect this daily sales wall series. Okay, so as you can see, so this is again not sorted, so of course we can sort them. And so it's a good practice. Okay, so what we can write, so daily sales wall dot sort index. Okay, and then we'll write in place is equal to true. Okay, so now um, we can plot it in another way, right? So here we don't even need to write something like earlier that we did. We wrote something like plt dot plot, and then in the plot method we provided the panda series as argument. Okay, but we can do it in a slightly different way. It's not that different, but slightly different. So because daily sales wall is a panda series, so if you write dot, so you'll be able to see a lot of functionalities associated with the series. And somewhere down the line, so as of course it only shows some top 50 or something like that, so we can write pl, and as you can see it suggests plot, right? So this method is already associated with a panda series object, right? So this is already available, so it's not like a very different thing, because the developers felt the need that, of course, when we are building pandas to do a lot of exploratory data analysis, and visualization is one of the key components of that analysis. So they went ahead and added a few methods on your basic, let's say, panda series object or pandas data frames. Okay, so we have this plot, and we can simply just yeah, call this method plot, okay, for this data frame. And similar to the last uh, example, or the last objective which we solved, so there also we set the title, the y label and x label, right? So when you do run this, right, so your plt object will get updated. And so now you can update the title and update the x label, y labels, etc. And we don't need this because we have already set this earlier, right? So now as you can see, so this is for the month of July 2018, and our x label is date, and y label is total number of sales as we have provided here. And then we have the sales in the month of July 2018, which is the chart title, right? And as you can see, so it's very interesting chart, right? So this is for the month of um July, right? So I'm not sure. Can you guys tell me that what was the day? Essentially, on 1st July 2018, what was the day? Can you tell me whether it was Friday, Monday? Can you just quickly Google it and let me know? Uh, yeah, can anyone tell me which? Yeah, so it was Sunday. Okay, okay. So first was Sunday, then second was Monday, then we have Tuesday, then Wednesday, then you have Thursday, and then we are seeing a spike on Fridays, and then a drop on almost very close to zero on Saturday, and then it's sort of remaining very yeah, almost same on Sunday. Then it's yeah, peaking up a bit on Monday, right? And then This is Tuesday. So we are seeing peaks on Friday, right? Can you confirm, guys, if that is the case? So we are seeing sales peak on Fridays, right? Can anyone just confirm over the chat? Okay, yeah. So we're seeing, yeah, yeah, peak sales on Fridays every week. Okay, and in fact, in the last Friday of the month, so that sales actually was the highest if we talk about daily basis. Okay, so the reason I'm guessing this might happen that yeah, people are approaching the weekend, and as you guys have already told that yeah, uh, it's very close to the weekend, and so people are relatively free, and they can go out and yeah, have a look at different properties, and this can also be well correlated with uh, the Friday sale if there is any, right? So that could also be one of the things. Okay, I'm not yeah thinking that there would be 50% sales, but there would be some sort of discount, or maybe the HM land registry department, they might not be very active on the weekend, so Friday is the most active, is the last working day for them, so that's why we're seeing very high sales on these particular days, right? So uh, so uh, whenever you are doing any such analysis, right? So let's say you came up with a daily sales trend in the month of July, right? So you need to ask yourself whatever you are seeing, right? So here uh, we can see that there is a proper periodic behavior, that on every Friday sales are spiking up, and then sales are pretty much almost zero on your Saturdays and Sundays, that is during weekends, right? So it might be that there's hardly any such activity going on because the registry might be closed during the weekend, so only the pending ones are getting cleared there on weekends, but there could be some other reasons as well. Okay, so you'll have to inspect a lot, right? So right, so sales people are also working harder to sell before the weekend, so that might be one of the case, uh, right? So but in fact we're seeing extreme spiking essentially from Thursday to Friday, right? So a lot of people are actively selling these properties to different people who want to own a property, and of course these people who want to own a property, they're having a lot of time on Fridays to go and check. Uh, okay, so Abhijit is saying that PLT dot plot is giving weird plot. Have you run that percentage matplotlib inline? So I think that would be the case. But of course, you can ask this question on the Slack channel, and I'll try to get back to you. Okay. All right. So this is the second objective. Let's go ahead and look at the third objective. So now what we want to do, we want to compare the daily sales volume of different property types in July. So what would be a good way to do this? So now we want to not only look at the overall sales, but we want to dissect it across different property types, and we want to explore how the sales of different property types which are being sold in July, right? So you know that our DF only consists of those observations or those sales which happened in the month of July, right? So above we subsetted that. Okay. So now what we can do. Okay, so we'll be using the group by operation here, and we want to group by not only on sale date but also on the property type. Okay, and what we can do, so instead of sale date, I can provide TID here, which we have, and so essentially this will give you the count. Okay, so let me first run this for you guys, and I'll just talk about the unstacked part in just a while. So let us first see what this gives us, right? So this gives us something like this. So here we have some levels. So right, so within for a particular date, we have different property types and their corresponding sales. Then for each such date, we have different property types and their corresponding sales number, right? So now we want to give this the shape of a proper data frame, right? So we want to have proper rows and proper columns, right? So this is not what appears to be in this particular case, right? So how we can do, so we can call the unstack method. And if we are aware, so unstack essentially will, we want to unstack these property types. So will be moving this property types in columns, and your sale dates will be the rows. Okay, so that is what unstack will do. So essentially we're unstacking this particular data in which our property types will be the columns, and the sale dates, so those will be your row values. Okay, so let's go ahead and see what daily price has. So now we can check daily price, right? So here we have 31 rows. So as you can see, sale date is here, and then you have DFST as different columns. And of course, there is property type which you might find it difficult to comprehend, but just don't worry about it. Just think of it in this way, that DFST are the columns in this particular data frame. Okay, so in fact, what we can do, so let's, we have already run this. So let's see what are the columns in our data frame, right? So we have these columns, right? So D, F, S, T, and as you can see, the name of this, as in there are levels. So property type is a level, and it has these values within it. And if you just if you pass them to a list, okay, so you'll only get these values. Okay, so right, so you're seeing only these values. So these are essentially your columns. Okay, so DFST are your columns, and then so for detached, semi-detached, and then you have flats, and then you have terraced. Okay, so these, you have these sales number here and things like these. Okay, so for all the dates we have the sales for these particular property types. Okay, so now we want to visualize this particular bit. Okay, so we want to see how does the sales for different property types look across the month of July. Okay, so what we can do, so we'll just use the same code which we have used in the last objective. So we have the daily price, and then we can simply call the plot method. Okay, and of course I'll just omit this from here, and this is what we have already written above. Okay, so now I'm setting the title, Y label and X label. Of course there are different methods which will decorate your chart apart from these title, Y label and X label. So as you can explore these parameters. So maybe you can go through the documentation, but you can set the X ticks as in the units of your X axis, the units for your Y axis, etc. So there are a lot of things which we can do. Okay, so let's go ahead and run this, right? So for different property types, you can see all their line charts in just one graph, right? So now you can make an assessment that which property sales, which properties are being sold the least, and which properties are being sold the most. Okay, so from here I think you can definitely infer that for the month of July, you are seeing this orange, right? So flats, they have the I think they have the least sales, and then you talk about the terraced and the semi-detached. Okay, so they have the highest sales. Okay, so as you can see here, so this is what we are observing, right? For different property types. And let's just go back and see what were those property types again, just to confirm, right? So D is for detached, S is for semi-detached, F is for flats, and terraced, right? So terraced houses, they are being sold a lot. Okay, okay, right? So terraced are being sold a lot, and also the green ones, which is your semi-detached, and but the flats are being sold the least. Okay, there could be some reasons for it. I'm not actually sure why this is happening, because I do not honestly understand the demographics of how what people prefer in UK, right? What kind of properties. So maybe we'll have to explore a lot of other things to understand to come to this conclusion. So why are these sales happening yeah, the most, and why the flats are being sold the less, the least. Okay, so we have one column which is price, and this might be related to price of these properties, so we can do that as well. Okay, so so what we can do, so here uh, we can draw comparison among different property types in terms of sales. So here we'll be able to figure that out. So uh, okay, so we'll see that. Okay, so in fact we can correlate the sales with the prices of these properties, but yeah, that objective will come next. So for now, our objective is to uh, represent a particular piece of information in term in form of a useful chart, in form of an interactive chart. Okay, so now what we want to do, we want to draw a comparison among different property types in terms of sales. Okay, so here again, for property types, I'll just do value counts. Okay, simply value counts, and I'll have, yeah, information about these four property types. And now there's a very good way to compare these numbers. So here, of course, you have four numbers, and you can simply say that, yeah, this looks the highest for T, but the lowest for F, right? But let's say if you have different, a lot other categories, so how do you differentiate? And how do you, yeah, just look at or summarize this information in a very visual way? So what we can do, so we can yeah, write this series which is sales by type, and then we can call this method plot. So earlier when we were calling the plot method, we didn't provide any argument, but there is an argument which is kind, and if you provide bar, so this will give you bar chart, right? So I think you guys are familiar with the bar chart or the histograms. So here again, I'm setting the title, Y label and X label. So now as you can see, the highest sales was recorded in the month of July for terraced properties. Then almost equal number of sales were registered for semi-detached. Then detached, and the lowest were recorded for flats. Okay. So now what we want to do, we want to find out the average house prices for different property types in July. Okay, so what we can do, so in our group by method, right, so we can use the group by method. So of course it doesn't make sense to use the value counts, but what we can do instead, so we can find the average value of all the prices, so average price of all the property types, right? So you have this property type D, under which you have a lot of different properties, right? And you have their prices, so you can aggregate them, as in we can take the mean of them and can find the average property or the price of the property for that particular property type. Okay, so let's go ahead and run this. Okay, so I think, yeah, this does not need much explanation. This is sort of explanatory, right? So this is the column on which we want to do some aggregation, so that's why it's appearing here, right? So and then we can see average price property type, and then what we can do, so here now we'll not use the usual plot method that we are using, but what else we can do, we can create an instance of a figure object. Okay, so we can create an instance of the figure object. So let's say I can create this instance which I'm calling as AX. Okay, and I'm creating this instance here. So what I'm writing, so I'm writing the series, then the plot, and then you have something like plot dot bar. Okay, and you can of course provide the figure size, font size, etc. So those things are not that relevant at this point, but there are options. So in this way, so remember earlier when we used plot, and here we provided kind is equal to bar. Okay, but we can do something different. So we can write dot plot dot bar. Okay, and here in the bar method we can provide the arguments like font size, figure size, etc. So what this line will do, so this will create an instance of a figure object. Okay, which will be of PLT type. Okay, and then here, so for this instance we don't have a title method, but we have the set title method. okay, which will set the title for this figure object. Okay, and similarly, we don't have the X label method or the Y label method, but we have instead set X label and set Y label, which will set the corresponding labels for this particular figure object, okay, which I'm storing in AX, okay. And of course, here you can specify the font size too. So there are a lot of different arguments, so you can explore. So I'm not expecting you guys to remember all of these things, because there are different ways to get the same chart, but I'm just trying to demonstrate that there are different ways to do this. And of course, you cannot remember each and every such different constructs, so it's better that you just keep in mind what you want to do and simply Google it, right? Something like uh, uh, create create histograms uh, in matplotlib, okay, something like this. Okay. So you can find good answers from here, right? Maybe I can add let's say I can simply write create histogram in matplotlib stack overflow, okay. So, okay, so you can find good answers from here, right? So let's say if you're confused, so here as you can see plt.bar, so there are of course different ways to create a bar chart or a histogram, right? And as you can see, so depending upon the use cases, you can do that. I think this is a bit different. So you can use matplotlib. You can we can of course do this thing with cbond, but we are yet to explore that, okay. So I'm just trying to give you an idea that you should only be aware that what you want to do. Rest, how you want to do those things, you can simply Google them, right? And everything is available. So you can go through the official matplotlib documentation, and everything will become clear, right? Once you understand that a lot of objects in Python, they are essentially classes, and then for different classes you have different methods within it, and you have attributes for them. So once you're able to understand what this particular object is, okay, then you can understand, so this is a class object, okay, so there must be some attributes for it, which I can access by writing the class name dot, or an object of that class, okay, or an instance of that class. So what we can do, so we can write that in variable or object name dot, and then we can write the name of the attribute to access the attribute for that class object of that class, or we can also call particular methods defined for those class, right? So you need to keep these things in mind, and these are the most important things, right? So you need to understand which variable is which object, right? So once you have understood that, you have solved most of your problems, right? So a lot of people actually get confused that this is this is that, okay, but you need to keep in mind that you need to understand how data structures work, and how can you identify those data structures, right? So let's say I have average price type, right? So if you write dot, right? So as you can see, so this is essentially saying that frame or series, okay, and you can see there are a lot of different methods associated with it, okay. So, and of course you can print the type of it to understand what class or what object that particular variable is, okay. Okay, so Sumanta is asking, of course, this is a very generic beginner level question, right? So why we need instances as we could do it with plot, right? So of course, there are different ways to do this, and by time you will be able to actually appreciate why there are different ways to do the same thing, right? So you don't want to restrict yourself, because dot plot method might work for certain cases, but it would be much better that you can create a figure instance of a figure object or a PLT object, and perform or add a lot of decorations on top of it, right? So you would want to have a lot of flexibility with you as well, and you will not be able to appreciate this today, but when you do a lot of visualization, you're doing a lot of exploration, so you'll I guess stumble upon some of the issues with certain methods, and how different methods are there to kind of incorporate the shortcomings of the existing ones, okay. So don't worry about it. but just keep in mind that yeah, there are different ways to do the same thing. Okay, so and all these different techniques or ways will have their own importance, and that will of course depend upon the use case. Okay, so okay, so let's run this particular piece of code, and our objective was we wanted to see which are the yeah most expensive property types. So as you can see, D is the most expensive property type, and then terrace is the least expensive, and then S is between here, yeah, between the, so they are in middle sort of, right? So flats are expensive, but they are second expensive in fact, right? And terrace are the least expensive, and so as you can see, so terraced and semi-detached. Okay, so these two. Sorry. Okay. Okay. So these two are the least expensive property types, and that's why we are seeing that their sales numbers were quite the highest. Okay, out of the four, right? So thus we have an explanation that yeah, why these property sales were higher, because these properties were the least expensive, especially SNT, which are semi-detached, and the terrace properties. Okay, so are you guys able to understand this particular bit? So okay, okay, all right, and okay, so so now let's have a look at another interesting plot, which is box plot, right? So this is also called as box and whisker plot, and this is a very good way of showing the distribution of data in a 5-number summary. So what are these 5 numbers? So these 5 numbers are min, then the first quartile, then the second quartile, the third quartile, and the max. Okay, so I hope yeah you guys will learn about all those things when we talk talk about descriptive statistics. Okay, so yeah, these things will become clear, but I think you already know, right? So what is min? Min is the minimum value, max is the maximum value, and then you have your first quartile, which is the 25th percentile. Then second quartile is your median, which is the 50th percentile, and then you have third quartile, which is your 75th percentile, right? So I think you guys would be able to comprehend these numbers or statistics. Okay, so what we want to do now, so obtain the average house price distribution for different property types. Okay, so now we want to do this particular task. Okay, so let's go ahead and run this particular piece of code in which I'm group buying over sale date and property type, and then I'm finding the average prices of those properties for those dates, and then I'm just applying the unstack method to unstack, right? Because why do we need unstack? Because here you are group buying on 2 columns, right? So when you have multiple columns on which you are group buying, so that's why we felt the need to use the unstack method, so that your sub levels, right? So in your group by you have a bigger level, and then you have sub levels within a particular bigger level, right? So we can unstack those, so we'll convert those sub levels as columns, and that is what unstack is helping us achieve. Okay, so let's go ahead and run this. So yeah, so this is the data frame, and yeah, so this is what we just obtained earlier, and here, because this is a data frame, so we can call the plot object or plot method, and we can provide kind is equal to box, right? So earlier, remember, we used a kind is equal to bar for bar plots, but we can get the box plots, and here we're using the usual, so we are not creating the instance here. Okay, that's a bit cumbersome, but we can simply set the title, y label and x label, and let's see how it looks, right? So now, as you can see, so this is a box plot, and I'll just try to tell you what these numbers are. Okay, so this is I'll tell you firstly. So this is your uh, which number? So this is your Q1, which is quartile 1. This is your quartile 2. Okay, and this is your median. Okay, this is your quartile, sorry, this is quartile 3 in fact, and this is your quartile 2, which is median. Okay, so the box is essentially, this is what we call as interquartile range, right? So essentially all the observations which are between 25th percentile and the 75th percentile, so that box, right? So this box is what we, this particular thing range is called IQR, or short for interquartile range. Okay, and these are what we call as whiskers, and they essentially okay, so we have some outliers here. So this is the minimum value, and then you have the maximum value, and these are the whiskers which are placed at I'll just show you that, one second. Yeah, so they're set at 1.5 times IQR Q3 minus Q1, right? So IQR is essentially Q3 minus Q1, right? And if you multiply that by 1.5, and yeah, so they are situated from your Q1 in yeah, here, and they're situated from Q2 Q3 here, right? So these are your whiskers. Essentially they're located at 1.5. So if you were to write them, so one is of course Q1 minus 1.5 IQR, and then you have essentially Q3 plus 1.5 IQR. Okay, so these are our whiskers. Okay, so they are sort of yeah, kind of so one important concept here is I'll just like to highlight, right? So as you can identify, right, so this is an outlier, right? So this particular observation takes a very high value, right? So as you can see, so this is around 5k, and this value would be around what, more than 5.5k, right? So this is really expensive property. And then you would have some values, let's say for this particular property type D, so this is the least expensive or the cheapest property type, right? So these are what we call as outlier. In fact, everything outside the whiskers, everything outside the whiskers, and so those are treated as outliers. Okay, so those are outlier observations. And what is the meaning of outlier? That they do not conform, as in the spelling of conform is conform. Okay, so they do not conform to the usual distribution of the data or the average distribution of the data, right? So usually what we say that all the observations which are lying between these values, right, so they are sort of uh, uh, in the usual place, or they're taking usual values, but all the other observations which are taking values outside, or yeah, either below or above, either below this bottom whisker or above the top whisker, so those points are considered as outliers, right? So in this case, this one and this one, so these are outliers. Okay, so I hope, yeah, you guys understand what is a box plot, right? And similarly, as you can see, so it's a very interesting, right? So for D type, right, so the median price is somewhere around let's say 4.3 lakhs pound, right? And then here for property type F, which is flats, so this is closer to approximately 3 lakhs pounds. And then for this particular, right, so the median is the green line. Okay, I hope you're able to see green, right? Assuming nobody is colorblind. So now for property type S, so it's around 2.5 lakhs, right, the median value. And this particular median value for the property type T is a bit lower than 2.5, so I can take this to be around what, 2.3, something like this, right? So so this also gives you a very good understanding of how your observations are placed, as in what are the prices of different property types, right? So as you can see, for terraced only, there's one house which is very highly priced. In fact, with respect to, let's say, the property type D, which is in fact the most expensive property type, a particular house in your property type T or terraced, that is really expensive. right? So it's around what, more than 4.5, greater than 4.5 lakh, right? So this is an outlier for this particular um, property type, right? So this observation, it does not conform to all the observations which uh, are present in the property type T. Okay, so yeah, so whenever you are plotting box plot, right? So you will be getting the yeah, outliers as well, right? But the usual data or the conformal data in a way will be between these two whiskers, right? So these points will be treated as the usual ones, not the outliers. Okay, but all these points outside the whiskers, these points, these dots especially, right? So these are considered to be outliers. Okay, so I hope, yeah, that makes sense. Okay. All right. So now we have explored a lot of the functionalities available in Matplotlib. Now it's time to explore the Seaborn library. And Seaborn is a library which is built on top of Matplotlib. As Pandas is built on top of NumPy, so Seaborn is also in a way, yeah, built on top of Matplotlib, and it's very useful and very handy to play around with your Pandas data frames, right? So the Seaborn provides a lot of very useful and one-liner set of codes for your data frames, right? So we'll see that example. So in this particular example, I'm taking a speed dating data set, right? So this is available in our path only. Okay. So okay, this was dir path. Okay. So now let's see how does our data look like, right? So you have a lot of variables, in fact 195 columns. So condition, wave, round, position, okay, then match, same race, age. So there are different set of information. So it's sort of like uh, so how much, let's say a particular person would rate himself or herself on intelligence, or how much fun they are, or how much ambitious they are, something like this. So there are a lot of different indicators for this. And right, so there are a lot of different identifiers. So like what is the levels of intelligence, or uh, there are a lot of other columns, right? So we have around 195 of them. So let's see what are the columns exactly. So so I'll just call this attribute dot columns, and we don't even need to, yeah, write values, right? So when you have a series, so there is a method on top of a series which is values. So when you call that, so that will split the array. Okay, that will split a numpy array. Okay, so if you have a series, let's say a sales is a series, so if you write sales dot values, so that will essentially give you a numpy array, because panda series is just an ornamented numpy array, because it just not only have the values but also the labels. Okay, so I hope, right? So there are a lot of different variables, right? The income, sports, right? Gaming, clubbing, reading, TV, theater, right? So there are a lot of different, and in fact, um, so uh, essentially I think they've also given the feedback for their dating partners, and they have rated themselves in terms of intelligence, etc., right? How much fun they are. So those sort of things are here, right? So but of course we'll not bother about all those things, because we don't actually have the data dictionary or the information about all these variables. But there are some variables which we can understand, yeah, explore and see what those gives us, right? So firstly, uh, okay, I'll just import NumPy because here, okay, so I'm subsetting the data for age. So essentially, I'm creating a series here, right? I'm creating a series in which I have age, and I don't want to keep those observations which are null. Okay, so essentially that's why what I'm writing here, right? So this particular expression, it identifies those observations which are nulls. Okay, and then if you write tilde, so it essentially reverses that boolean. So whatever that is true, so will be false, and so we'll be getting all those values in the age column which are not nulls. Okay, and then what we can do, we can write plot.hist. So this is the usual way, right? So we are not using SNS here or the Seaborn. Okay, so this is how the it looks like, right? So essentially it's the uh, free so which age group is most active on this particular dating site from which we have gotten the data set, right? So as you can see, younger people, so they are mostly using this particular dating platform, and they're very active. There are very few people, in fact, as you can see, there are some people who are around what 55 or 54 age, right? But they're also using this dating website, but they are sort of an outlier in a way. But usually, mostly the young people are spending a lot of time on these dating on this dating platform. Okay, so now it's time to use the Seaborn library. So again, so SNS is again a very widely used alias for Seaborn. And yeah, please don't ask me why SNS. I'm not sure actually, but yeah, you can write this statement: import Seaborn as SNS to import the Seaborn library. And now we can get the same histogram or the frequency plot, but just by calling this dist plot, right? So in SNS dot dist plot, right? So there is dist plot, which is short for distribution plot. Okay, and then you can provide your age, which is your series, and here what you need, what you're specifying, that hist is equal to true, as in you also want to show the histogram. Okay, hist is short for histogram. So let's go ahead and run this, right? So as you can see, so this is the average, so this is a distribution of age um, of people who are using this dating platform. And as you can see, most of the people are between 20 to 30 age group, right? So this is what the platform looks yeah, this is what the distribution looks like. And this is density. I'm not sure if you guys will be able to understand this at this moment, but only just focus on the bars, right? That gives you the frequency, and also don't bother about these numbers. Try to think of them as related to these particular absolute or raw numbers, okay, which is essentially the count of those number of people. Okay, and also one more thing I didn't check. So in your dating data, let me see what is the shape, right? So we have around 8,000 observations and 195 columns, as you already know. Okay, so it's very easy, right, using SNS to just get the histogram, right? So here we had to do a lot of stuff. Of course, this part is common to both of them, but here we were setting the X label and Y label. But as you can see, X label is already set, and the Y label is density, because this is a distribution, in fact a probability distribution. So yeah, don't worry about it, just focus on the bars here, or the histograms, right? Okay, now one important thing is that using Seaborn we can get correlation heat maps as well. So what is correlation? So let's try to first understand what's correlation, right? So I have two lists here, one is X and another is Y, right? So X is essentially 1 2 3 4 5 6 7 8 9 10, but Y is just one number added to all of them, right? So it's from 2 to 11. Okay, so what do you think? These are positively correlated or negatively, right? So obviously positively correlated, because you can already always find a mapping from X to Y, right? So you can find a mapping from X to Y in this fashion. So if we have this particular value, let's say I, so the corresponding value in Y will be I plus 1, right? So this is positively correlated data. Okay, so okay, so yeah, okay. Now we have negatively correlated data. So essentially, what is the meaning of correlation? That let's say if the trend or the values of a variable is going in one direction, right, and the corresponding values for another variable is going in another direction, they are behaving in, let's say, an opposite direction, so we can say that they are negatively correlated. but let's say if they are moving in the same direction, as in, let's say here, if you plot x, right? So let's say if you plot x, so you can say that, yeah, this is x, and then you have y, which is this, right? So as we move along this, so these values increase, right? And so essentially, this is the meaning of correlation. So if the change in the value of one variable um, is related with the uh, yeah, same change or a similar change in the values of another variable, and they seem to be, yeah, moving in the same direction, so we'll say that those two variables are positively correlated, right? And then you can have zero correlation, as in the values of one variable will not even affect the values of other variable, right? So will not have any sort of information, right? So here I have x is equal to 1 comma 2 comma 1 comma 2, and then you have 1 comma 2 comma 2 comma 1, right? So these two are uh, these two have zero correlation, right? So you cannot find any such mapping so that you can get y from your corresponding x's. Okay, so now let's create a data frame of these two. So maybe what I'll do, I'll run this particular thing, which is negatively correlated data, and I'll create this data frame using this list, these two lists, and this is my data frame, right? So x is from 1 to 10, and then y is in the reverse direction, 11 to 2. Okay, so there is a LM plot in SNS. Okay, and if you can hover over this, so this essentially plots data and regression model, so don't even have to worry about it, but we can see how these two variables are uh, negatively correlated, right? So if the values of x increases, right, the values of y decreases. Okay, so this is negatively correlated. Okay, so if the values of x, as you can see, if it increases from 1 to 10, the values of y decreases from 11 to 2. Okay, so this is what we refer as negative correlation. Okay, and then there is an important core method, which is short for correlation, and this is available, this is a method available with your pandas data frame, in fact, right? So this is the core method, and this will give you the amount or degree of correlation between two variables, right? So there is a way to calculate the correlation, but of course these things will be taught to you in descriptive statistics, so you don't have to worry about this as of now, in fact. Right. So these are the values. As you can see, x is of course 100% or correlated with itself, but as you can see, x and y, they are almost 99% negatively correlated. Okay, and of course this is a symmetric matrix, because the correlation of x with y is same as the correlation of y with x. Okay, so now let's have these five variables in our data set. So one is gender, the another is shopping, then gaming, then concerts, and then music. Okay, so let's keep these columns in our data df, and we can find the correlation of these variables among themselves. So as you can see, so of course gender is 100% correlated with itself, and then okay, one important thing, so gender takes two values, 0 and 1. 0 is for females and 1 is for male. Okay, so as you can see here, uh, gender is negatively correlated with shopping, as in people with gender value 0, that is females, uh, uh, they have a higher shopping tendency as compared to males. Okay, in fact, okay, I'll just okay, and then you have gaming, right? So men are more interested in gaming, and similarly, as you can see, concerts. So of course the correlation for shopping is higher if you talk about gender, and if you talk about gaming, it's there's only 22% correlated with gender, and then concerts, the correlation is even less, so it's around 13% negatively correlated. That means men have less tendency to attend concerts. Okay, and then the music as well. So female, yeah, so it's again negatively correlated. So females have a higher tendency to uh, listen to music. Okay, and then if you talk about concerts or music, so let's talk about this particular value, right? So this is concerts and music. So people who prefer going to concerts, they also like listening to music, right? So this is around 66% correlated. Okay, and all the diagonal values will be 1. As you can see, this value, this value, this value, this value, this value, and then this value, right? So all these values will be 1 because they are the diagonal values, and gender correlation is 1, shopping correlation is 1, right? So the correlation of a variable with itself is 1. All right. uh, so now using SNS, we can get the heat map. So these numbers might not be that very yeah, they might not be very easy to interpret. Okay, especially as if you had 10 columns here and then 10 columns here, right? So it will not be easy to read all those numbers, but we can use the heat map and we can understand this in a much better way, right? So here I am setting the PLT figure size, and then I am calling this heat map method and just passing this correlation DF. This is the DF. I'm passing in heat map. Okay. So let's see what this gives us, right? So as you can see the scale, so the lightest shade corresponds to 100% correlation. The darkest shade corresponds to the 100% negative correlation. Okay. So this is, as you can see, if you're able to see minus or not here, so this is in fact not 0.2, but this is minus 0.2. Okay. So black represents minus or negative correlation, very high negative correlation, and the light shade represents very high positive correlation. Okay. So as you can see, all these diagonal boxes, they are 100% correlated. Needless to say, they are the same correlation with the same variable. But now, as you can see, gender and shopping, right? So this is shopping, and so yeah, shopping is this and gender is this, right? So it's negatively correlated, as in and very highly negatively correlated. So that means females have a higher tendency to shop. Okay, and as you can see here, this is the orange shade, and it's somewhere around here. In fact, yeah, somewhere around here. And as you can see, people who listen to music, they also go to concerts a lot. Okay. Okay, so this is the correlation heat map, and in fact we can make it more intuitive. So as in we can set the minimum value for the color scale at -1. So there are a lot of things which we can do. So you can also annotate the value on top of this, right? So here we are only seeing the color, but you can also annotate the value of the degree of correlation here as well, right? So here you can provide annote is equal to true, which is true, which is essentially saying that annotate those values for corresponding boxes. Okay, and okay, so C map is short for color map, and you can provide specific values. So you can find the list of possible values in the official documentation of Seaborn, but you don't have to worry about it, right? So you can simply Google this, and then you have vmin, right? Yeah, don't even also bother about this, right? So this is in fact the minimum value, which is set at -1, right? So because the correlation, the least possible value for a correlation is -1, and the highest possible value for a correlation is +1. Okay, so this is what we are getting. So essentially the same heat map, but with different colors and gradients, and with some annotation. Okay, now let's talk about two-way plots. So this is also really interesting. So let's see how a dating data DF looks like. So we have 5 columns, remember, and there are some scales of values. So let's check the shape as well. Okay, now so we want to get the two-way plot. So how does this work? So there is joint plot in SNS, right? So you can write SNS dot joint plot, and then in X you can provide, let's say, concerts, and then in Y you can provide music, and then you need to provide the data. So this data is your dating data DF. Okay, so let's run this. So I hope you will be able to read this particular bit. Okay, so as you can see, so these are the values for your concerts, and these are the values for your music, right? So of course, you have a lot of points, right? So you have around how many points? So 8,000 observations, right? So you have around 8,000 observations, and you have the corresponding values of music and concerts. And because these two variables, they take values and scale. So music take values from 0. So it takes values like 0, 1, 2, right? So discrete set of values. It's not a continuous spectrum. Okay, similarly with the concerts, so concerts also take values like 0, 1, 2, something like this, right? So here if you talk about 0, so here this we have a lot of observations for which concerts is 0, and your music is also, I guess, it's not 0 but it's 1 in this case, right? It could also be 0. Then let's say if you talk about these particular observations, so these correspond to yeah, those observations for which concerts is 9 and music is 7. Okay, so people who have rated themselves for music as 7 and for concerts as 9, so they are all coming up here, right? And I just want to know from you guys, are you able to understand why are we getting these grid equally spaced points in this fashion? Um, uh, are you able to understand? Okay, all right. So I'll just explain this again, right? So music take these values only, right? So from 0, 1, 2, 3, 4, 5 till 10, right? Similarly, concerts also take value from 0, 1, 2, 3, 4 till 10. What these values represent? So essentially what happened that people filled out these surveys and they rated themselves in terms of their likelihood to enjoy this particular thing. Let's say how much they enjoyed music or listening to music, or how much they enjoyed going to concerts, right? So this is how they have rated themselves. So some people do not like listening to music at all, but some people do like, right? So they will rate themselves 10, right? Similarly, there will be some people who will rate themselves very low. Let's say if they're not interested in going to concerts, but some people who are very interested in going to concerts, they will rate themselves as 10. Okay, so yeah, so I think, yeah, you guys are able to now understand why we are getting these values, right? So this is not, so let's, if you talk about this particular dot, right? So this is not just one observation. This might be, let's say, 100 observations, but because for all those observations, concert is taking the value 5 and the music is taking the value 6, right? So maybe I can show you those that particular, right? So let's say, yeah, here let's say we find out people who have rated themselves 6 on concerts, that means this, and rated themselves 8 on music, right? So maybe we are focusing on these particular observations, right? These. So let's go ahead and run this. So how many observations are we getting? So 329 rows. So you might only be able to see one dot, but this is in fact a lot of dots there, right? And because all those observations are taking only those values, so they are occupying that particular space. One interesting thing to note here, so it's not only the scatter, so this is what we call a scatter plot, right? So this is what we also call a scatter plot, right? So let's say if you have two variables, let's say if you talk about numeric continuous variables which take values in a continuous spectrum, of course this is also a scatter plot that also makes sense for variables which take discrete values. But let's say if you have two variables and if you just plot yeah, those observations corresponding to their value, so this is what we call a scatter plot. Okay, so we have one more addition on top of the scatter plot. So this is your histogram as well, as in most of the people have rated themselves for concerts with around 7 and 8, right? 7 and 8 or 6 as well. Okay, so 6 to 8 is the general population for or this is the average rating what people are giving themselves in terms of their interest in going to concerts. Okay, and then if you talk about music, so a lot of people have mentioned here, right? So they are very interested in music, right? So 8, they have rated themselves 8, 10, 9, 8, something like this, right? And because we can see that there is a proper sort of increasing trend in a way, right? So if you increase if the value of concerts increases, music also, the values of music also increases in a way, right? It's not that clear, but there is some a positive correlation between these two variables, and we have noticed that earlier as well, right? So what was the correlation earlier between music and concert? So this was around 66%, right? So this is quite positively correlated. So if you, so you'll find most of the people who are rating themselves higher in concerts, they will also rate themselves higher on music, right? So here we're talking about correlation. There's a very popular phrase people say that a correlation does not imply causation, right? So it's not like I am read I'm interested in going to concerts, so that's why I am also interested in music, right? So it does not work in that way, right? So there's no causal effect, so there's no cause effect situation, right? So concert, my interest in concerts is not triggering uh, the interest in music. It might be the other way around, that I'm interested in music, and I, that's why also I might want to, yeah, go out to different concerts and yeah, hear live music, right? But it's correlation. Correlation does not imply causation. Okay, so when we look at two variables and see their uh, uh, and study their relationship, right? So if we are quoting that, yeah, these two variables are correlated, it does not mean that the one variable is affected, or whatever the values that variable is taking, it's because of this particular variable, right? So they seem to be aligned in a particular way. That could be due to numerous reasons, but we cannot definitely say that, yeah, my interest in concerts is driving my interest in music. Okay, so I hope, yeah, you guys understand that bit. Okay, okay. So here, as you, okay, so I think you understand. So this is called a joint plot, because here we'll not only have the scatter plot, but we also have the dist plot on top of it, right? So on both the axes we have, and it's much, it's quite, what should I say? It's better to read in a way, okay, and it's more filled with information in a way. Okay, so if you were just given the scatter plot, you might not have found out a lot of details, right? Because a lot of values, let's say for concerts which are 7, right? So you don't know if people are rating themselves 7 or 6 or 8, right? Which number is the highest, right? So we have this on top of this scatter plot, so this gives us a lot of additional information, right? So that's why this yeah, two-way plot is quite helpful, right? So these are some basic type of plots which we have discussed today, right? So we started with line charts, and then we looked at some bar charts, and then we also looked at box plots, and then here we looked at joint plots. We also looked at correlation heat maps. So there are some few more interesting plots, like there's a violin plot which I've never used, but there's some other type of interesting charts and plots, which you, of course, you can explore, and I think you'll be able to understand which chart to use as and when you practice your problems and see, yeah, I can depict this information this particular way, right? So of course, this is dependent upon your discretion, and how how well you're able to think about that particular analysis and how to represent that in terms of graph. So yeah, so use your best discretion, and always think that, yeah, how can I present this information? So once you understand that, so let's say you think that, yeah, heat map should be a very good way to visualize this particular thing, right? So let's say if you're exploring relationship between different variables, so heat map would, correlation heat map would be a good thing to get, right? And you can simply, yeah, search how to get the correlation heat map, and you can find a lot of very, yeah, easy syntaxes, or you can of course explore the official documentation. Okay, so let's yeah, get on with the quiz, and then we'll, yeah, conclude this session for today.